Hey guys, so I'm going to be doing some more examples on the quotient rule, and I'm going to call these examples step-by-step examples. So I just want to explain what I mean by the word step-by-step. So I am really introducing a new example type with this, and I'm curious to hear what you guys think and if you want me to keep making examples like this. So if I use the word step-by-step, this is going to be more drawn out details, really at a slower pace. So this will be a little bit different from how a lot of my example videos go. I've gotten some feedback that sometimes you want to just really draw out the details, so that's going to be kind of the idea here. So here are the two examples I'm going to go through in this video, and we're just going to go through the whole thing. So let's get started with the first one. And so we're going to be taking the derivative. So just as a reminder, here is the quotient rule that we want to use. And what I'm going to do in this case is I'm also going to simplify this as far as I possibly can. Okay, so first things first. So just as a reminder, so here's my f of x. So the top function is the f of x, and the bottom function is my g of x. And actually, I'm gonna color code these two just to make it a little bit easier for us to look at. Okay, so what I want to do here is I want to use the quotient rule right here, and these are kind of my guides, right? So I'm going to take f prime or g prime as I kind of go through this. Okay, so getting this party started. So I start by just taking what my g of x is, so I'm going to make no changes to this, so this will just be x, and I'll put it in parentheses. And then the next part of this is I have to take the derivative, this f prime of x, I have to take the derivative of this guy right here. So now let's work on this piece by piece. Okay, so I'm going to use the pink color here. So the derivative of 1 is just going to drop out. The derivative of x is 1. And then for this next part, this will be 6 times, so remember this square root of x is really x to the 1/2, so this will be 1/2 x to the negative 1/2, so subtracting 1 from the exponent. There's the first part. Okay, so now that's this part here. Now we're going to move on to the next part. So for the next part, first I just leave my f of x alone. So I'm going to put my subtraction sign, and then I'm just going to rewrite out f of x. So this is 1 plus x plus 6 times, I'm actually going to write this as x to the 1/2 just because I think that's going to be easier as we work through the problem. So that's my f of x. So now I move on to my g prime of x. So I take the derivative of this. The derivative of x is just 1. So I'll just write that out. And then I divide all of this by my g of x squared. So in this case, that's going to be x squared. So I'll just write x squared. Okay, so now what I'm going to do is I'm going to start working on simplifying all of this. So let me clear some space. And now what we're going to do is we're just going to start kind of distributing where we need to. So here I've got to distribute this x in, and I also kind of need to multiply these things together, so maybe I want to do that first. And then this one here isn't really doing anything, so I can just distribute this minus sign to the whole thing. So I'm going to really do this in pieces. So first things first, as I've evaluated this problem, probably the best first thing to do would be to just multiply these pieces together. So let's write out an extra line here. So this is still x times 1 plus, so 6 times 1/2 is 3, and then x to the negative 1/2. Okay, now for the second part, like I said, this 1 isn't doing anything, so I can just subtract this whole piece here. So this will be minus 1 minus x minus 6x to the 1/2, and then all of this over x squared. Okay, making room again. So now I can start working on distributing this part here. So just as a reminder, this x is really to the first power, so don't forget that. So I've got x times 1 is just going to give me x, and then x times 3x to the negative 1/2. That's going to give me plus 3x to the 1/2. So this is 1, this has an exponent of 1 minus 1/2, so we get this. And then I've still got minus 1 minus x minus 6x to the 1/2, all of this over x squared. Okay, so now I can think about collecting like terms. So as I look kind of down the line here, so notice that this x is going to cancel out with this x, and then I can combine like terms with this 3x to the 1/2 and this negative 6x to the 1/2. So I'll clear some space again. And so now if I work this out, this becomes negative 3x to the 1/2 minus 1 over x squared. Now I've made some space and I want to address one thing. So here's the derivative that I found, but just for funsies, I threw this into a derivative calculator. So let me show you the answer that the derivative calculator had. So here it is. So now you might be thinking, oh, did we get this wrong? Did we approach this the wrong way? And so this is like part of where you have to really learn how to flex with calculus and your algebra skills. Because I looked at the steps of how a derivative calculator went about this, and it went about this in a very different way that I actually don't think a lot of students would think of. So you have to be a little bit careful. And so sometimes you might get the answer, and so you have to have then the confidence to kind of push forward with this and say, can I manipulate this in some way to make this look like this? And we totally can. So really, the whole thing here is that this is all just multiplied by x to the 1/2. How would you know that? Well, you've got x to the 1/2 right here, so if I add 1/2 more, that would get me this x right here. So that's one thing that we've got to do. So let's do that. And this is something that you should do from time to time. It's a really good way to practice your algebra skills by forcing yourself to see if you can get an answer to match this. Okay, so whatever I do to the bottom, I have to do the top. So I'm just multiplying the top and bottom by x to the 1/2 just to see what I get. So I'm going to distribute this in. So if I take this times this, I get y prime equals negative 3x. So 1/2 plus 1/2 is just 1. So now this is negative 3x. And then moving here, this is going to be just minus x to the 1/2. And then this part here, so this is 2, which 2 is the same thing as 4 over 2. So 4 over 2 plus 1 over 2 will give me x to the 5/2. Now, I almost have this in the same format as this. So the only other thing that I would have to do differently is I would just factor out the negative. So the two negatives here, I'll just bring it out in front. So negative 3x plus, let's see, well, instead of writing this x to the 1/2, I'll write this as the square root of x to make it look exact, and then x to the 5 over 2. So you have to be kind of careful when you use some of those derivative calculators, because they might actually make you feel less confident. And it can also be a moment to kind of practice some of your algebra skills, because there comes a point when you practice this all the time where you look at this, and then you can kind of think through, oh yeah, if I just multiply this by x to the 1/2, I'll get to this. But that definitely takes practice and kind of getting your hands dirty with the algebra. So as I see it, these things and these things, I would take either on a test. But you know, if you're seeing just something different, that's why. If you're seeing this instead, it's not that you got it wrong, it's just a different approach. And that actually happens with a lot of these, particularly like quotient rule type problems. There's a lot of different ways you can manipulate them. Okay, so now let's move to this other one. So I've got the square root of x plus 1 over the square root of x minus 1. So just as a reminder, there's our quotient rule. So I would actually recommend, if you are trying to kind of work along with this, to just set up this first step, see if you've got that part, and then we can keep moving along together. So this part is obviously my f of x. This part here is my g of x, and I'm going to go ahead and just start setting everything up. So first I'm going to leave my g of x function alone. So I'm going to call this x to the 1/2 minus 1. I just like writing things in their rational exponent form when I'm doing this. And then I have to take the derivative of the top function here. So the derivative of the square root of x is 1/2 x to the negative 1/2. And then we know that the 1, this 1 will drop out. Okay, and now I'm going to go ahead and subtract this. So now I leave the top function alone. So I leave my f of x function alone, so those parts. So this is x to the 1/2 plus 1. Oops, and then I'm forgetting my own color coding system. So now I take the derivative of this part, this square root of x minus 1. So this is 1/2 x to the negative 1/2, and then the negative 1 will drop out. And then all of this is divided by my g of x squared, so this thing here I'm going to square. Okay, so now in this case, we have a lot of things to kind of sort out here. So let me make some space. And now it's super happy distribution time. All right, so I have to distribute this 1/2 x to the negative 1/2 to this thing here. So this could be an area where maybe you get a little bit unsure of like what's happening with the algebra. So if that happens, just write the whole thing out, right? So this is x to the negative 1/2. So if I wanted to figure this out, so I'm taking x to the 1/2 times 1/2 x to the negative 1/2. So sometimes people kind of second guess themselves on what to do with this. So just do a side calculation and just figure it out however it makes sense in your brain. So a lot of people are like, oh, well, I added up the two exponents and I get something to the 0 power, so does that equal 0? So that doesn't totally make sense. If I instead write this in a slightly different way, x to the 1/2 times 1 over 2x to the 1/2. Oops, that's 2x to the 1/2. Okay, so now think about this. The x to the 1/2 and the x to the 1/2, these actually cancel out, right? Because if let's see, I'll continue to work this out over here. This becomes x to the 1/2 over 2x to the 1/2. So this is what I mean. These cancel out, so this is just going to leave you with 1/2. So sometimes when you're doing these, this kind of stuff is going to throw you off. And it's totally worth your time to sit here and just kind of dig into the details, because it's really normal to kind of forget this kind of stuff and just to have a second where you got to really chug through it. When you start playing around with this more and more, you get a lot faster at it, but it just takes a little bit of investment. Okay, so coming back over here, this is going to be this x to the 1/2 times this. This ends up being just 1/2. And then the second part of this is minus 1/2 x to the negative 1/2. Okay, so that's me distributing this part here. Let me get rid of all this other green stuff. And now I don't want to lose the negative sign here, so I'm just going to go ahead and do this distribution here, but I'll put a set of parentheses around everything so I don't forget to distribute the negative sign. So I got the same thing, right? X to the 1/2 times 1/2 x to the negative 1/2. So we already worked all that out, so that's just 1/2. And then this next part is plus 1/2 x to the negative 1/2. Now, the other really normal thing to kind of wonder with this is, what do you do with the bottom? Do you FOIL it out or not? So I actually like to wait until I've gone a little bit farther, because sometimes you want to work it out, sometimes you don't, and it's not always obvious at this point in the problem. So just hold that thought for now, and let's keep going. So I'll make some space. And I'll go ahead and I'll just distribute this negative sign. So let's see, this is y prime equals 1/2 minus 1/2 x to the negative 1/2 minus 1/2 minus 1/2 x to the negative 1/2. Okay, and so now I can see some cancellations I can make. Still just gonna let this be for the moment. Okay, so looking at my numerator now, so we've got 1/2 and negative 1/2, so those are gonna cancel out. And then otherwise, these two things are like terms. So let's make some space and keep going. So I've got y prime equals, so negative 1/2 minus 1/2 is just negative 1. So negative 1x to the negative 1/2. And of course, you didn't have to write the negative 1, but I wanted to. And then I've got this square root of x minus 1 squared. Okay, so at this point, like it's not like working this out is going to allow you to do any other cancellations. This is not going to cancel out with this. So as I see it, you should just not work out the squared part of this, so don't work this out. But the one thing that we do want to do is we probably want to take this negative exponent and just move it to the denominator. So my final answer will be negative 1 over the square root of x times the square root of x minus 1 squared. And so that would be it for that one. Okay, so that's it for this particular video. So I'm really curious to hear if this is kind of the speed that some of you guys were interested in. I really have a philosophy that education has to be something that we flex our style to. So some of you might have loved this format, some of you maybe didn't. And that's okay. Like, everybody's got their own style. So I'm very interested in kind of with this channel exploring and helping people figure out their styles and having all of that available. So your comments are super, super helpful to me, guys. Thanks for watching. I'll talk to you guys later.